Today we will start a new chapter which is current electricity. Now what is current? Current is nothing but movement of particles. So in the case of water current, it is movement of water particles. In the case of electric current, that is movement of charges. Now I will take the example of water current, that is nothing but, for example, river. Now how can we measure the intensity of water flow or water current in a river? By placing an instrument and measuring how much amount of water has been passed through that particular area of cross section in 1 second. That is simply the measure of intensity of water current, right? Similarly, we can measure the current through a conductor using an equation Q by T. Current. This is very important relation. I will explain it for you. The total amount of charges pass through an area of cross section in 1 second. Now how can charges move across a conductor? What is the source for that? See, whenever we are just placing a conductor, there is no current, right? But at the same time, when we are connecting it with battery, there will be current passing through the conductor. What is the reason? Inside the conductor we have free electrons. Free electrons. Now when we are connecting it with battery, we have positive terminal here, we have negative terminal here. Okay, these are positive, these are negative. Now what will happen? This positive terminal will be attracting the electrons in this direction. At the same time, this negative terminal will be repelling, or the charges are moving from higher potential to lower potential. In the case of positive charges will move from higher potential to lower potential. Anyway, the electrons will be exerted by a force of QE. So here there is an electric field. What is the direction of electric field? This is the direction of electric field, E. Now we know that when we are placing a positive charge in an electric field, that will experience a force along electric field. The value will be Q into E. So basically the force is equal to Q into E. When we are placing a positive charge, let's say a positive charge of 1 coulomb, then the value will be 1 into E. So the direction will be along the electric field. Now when instead of Q charges, when we are placing an electron, what is the charge of electron? Minus E, right? So that will be minus E into E. Minus E is the Q into E. So what is the direction? Minus E into E means the direction will be opposite to E. Now if E is in this direction, this is minus E. The direction of force is in this direction. So simply when we are placing an electron or negative charges in an electric field, that will come in this direction, opposite to the direction of electric field. But at the same time, when we are keeping a positive charges, that will be moving along the electric field. That is an important concept. Now here in this case, electrons will be moving in this direction. Clear? That is producing current in this conductor. And how can we measure the intensity of current? By measuring the amount. Just keep a cross-sectional area and measuring how much amount of current is passing through that cross-sectional area in 1 second. That is the value of intensity of current or current at that point. Okay, thank you.